Welcome to this training video focusing on Snowflake Cortex Analyst. Let us explore how this powerful tool transforms natural language into actionable data insights, drawing on information from the sources. Let's get started. Snowflake Cortex Analyst is a powerful, fully managed feature that helps users answer business questions using structured data. It is part of the Snowflake Cortex suite of AI capabilities. This service is designed to bridge the communication gap between business users and the technical SQL database. It eliminates the need for users to manually write complex SQL queries to retrieve information from their data tables. The platform leverages large language models, or LLMs, to perform this complex translation from plain English language questions into executable SQL statements. This functionality is crucial for delivering fast, accurate, self-serve conversational analytics solutions. The goal is to delight business teams and non-technical users with instant insights directly from their Snowflake data environment. This is achieved reliably by converting natural language requests into precise SQL queries. This is achieved reliably by converting natural language requests into precise SQL queries. This feature allows for the acceleration of high-precision, self-serve conversational analytics projects. This process ensures that data exploration becomes intuitive and readily accessible to everyone. This feature allows for the acceleration of high-precision, self-serve conversational analytics projects. This is key. This is achieved reliably by converting natural language requests into precise SQL queries. This feature allows for the acceleration of high-precision, self-serve conversational analytics projects. This is key. Cortex Analyst makes complex data accessible and easy to use for everyone. We start with the user's natural language question, which asks for a specific business insight from their data. Next, Cortex Analyst takes this question and begins the complex, internal process of converting the plain text into a structured SQL command. This core function involves sophisticated text-to-SQL generation capabilities. This generated SQL query is then sent to the powerful Snowflake execution engine to run against the underlying structured data tables. Once executed, the result set is processed, providing the business user with the direct, accurate answer they requested from their data. This architecture ensures that complex data queries become immediate and highly intuitive. The system seamlessly handles all of the technical complexity automatically, making the data highly accessible. Generic AI solutions often struggle with accurate text-to-SQL conversion simply because database schemas inherently lack critical semantic knowledge. This missing knowledge includes definitions for business metrics and complex handling rules. Cortex Analyst overcomes this significant limitation by utilizing a semantic model or a semantic view. These are lightweight mechanisms designed to address the mismatch between how business users naturally describe data and how that data is physically stored in the database. The model is specified using a human-readable YAML file format. This file contains the necessary semantic information, such as more descriptive names, business synonyms, clear facts, and dimensions. For example, a business user might refer to gross revenue, while the column name is a technical abbreviation like AMT_TTL_PRE_DSC. The semantic model teaches the LLM that gross revenue is synonymous with the technical column name. This crucial context dramatically improves the precision and reliability of the generated SQL queries. This crucial context dramatically improves the precision and reliability of the generated SQL queries, making the tool much more effective for enterprise use. This robust mechanism is central to Cortex Analyst's high-quality performance. This robust mechanism is central to Cortex Analyst's high-quality performance. This diagram illustrates how the semantic model acts as the essential contextual bridge for Cortex Analyst. On one side, we have the business user, who interacts by asking questions using natural language. On the other side, we have the core database schema, which contains the raw technical table and column names. The semantic model sits between these two layers, providing the crucial semantic context that is missing in the raw schema. This model contains key definitions such as facts, dimensions, and synonyms. When the user asks a natural language question, Cortex Analyst uses the definitions provided by the semantic model to correctly map the business terms mentioned in the query to the actual underlying database objects, thus creating the accurate SQL. This design ensures highly accurate text-to-SQL translation, overcoming the inherent difficulty of deciphering technical column names like AMT_TTL_PRE_DSC from a simple user query, making the analytics process much smoother. This makes data retrieval efficient and reliable. This capability ensures that the AI understands the business intent. The primary workflow begins when a user submits a natural language question about their structured data, often through the convenient REST API endpoint or a custom application like Streamlit. Cortex Analyst's sophisticated LLM processes this query, utilizing the rich context provided by the defined semantic model to bridge the gap and generate a highly accurate SQL statement. Importantly, this generated SQL query is then executed directly against the scalable Snowflake execution engine, using compute resources allocated from your own virtual warehouse. This architecture ensures data remains secure and governed within Snowflake, adhering to role-based access control. A powerful feature is the support for multi-turn conversations. Users can ask follow-up questions, and Cortex Analyst retrieves the context from the initial query to refine the response. For example, after asking for revenue growth in Asia, a user can follow up with "What about North America?" and the system intelligently rephrases the request based on the history. This creates a truly dynamic and interactive data exploration experience for business users. This ensures continuity in complex analyses. The full conversation history must be passed with each request because the LLM does not store state. This is essential for maintaining context throughout the interaction. The full conversation history must be passed with each request because the LLM does not store state. This is essential for maintaining context throughout the interaction. The full conversation history must be passed with each request because the LLM does not store state. This sequence diagram maps the flow of a query within Cortex Analyst, including multi-turn conversations. The user initiates the process by sending a natural language query to the Cortex Analyst service, including any relevant conversation history for context. Cortex Analyst then immediately checks the semantic model to retrieve the necessary business definitions, synonyms, and context required for accurate translation. Using this semantic context, Cortex Analyst generates the appropriate SQL statement. This SQL query is then securely sent for execution within your dedicated Snowflake warehouse, ensuring governance and performance. The Snowflake warehouse returns the raw query results back to Cortex Analyst. Finally, Cortex Analyst processes and formats these results into a simple, natural language response, which is delivered back to the user. Cortex Analyst is not only a standalone feature but also functions seamlessly as a specialized tool within the broader Cortex agent framework. Cortex agents are advanced AI models designed to orchestrate across different data sources to deliver comprehensive insights. When a Cortex agent receives a complex user request, it analyzes the query to determine the required resources. If the question pertains to structured data, such as querying tables, metrics, or dimensions, the agent selects and utilizes Cortex Analyst. Cortex Analyst focuses solely on structured data, leveraging semantic views or models to generate precise SQL queries. This structured data tool works synergistically with other tools. For instance, Cortex Search is utilized by the agent when the request involves unstructured data, like searching documents or conversations, often for retrieval augmented generation, or RAG. This intelligent routing ensures governed access and compliance with enterprise policies across all data types. Agents can route across multiple semantic views for Analyst, multiple Cortex search indices, and even custom tools defined by stored procedures or user-defined functions. This comprehensive support for tool identification enables the delivery of sophisticated applications grounded entirely in enterprise data. This diagram illustrates how Cortex Analyst is integrated as a crucial tool within the Cortex agent ecosystem. The process starts with a user request, which the agent planner receives and analyzes. The planner's core job is to intelligently determine which tools are required to answer the query accurately. If the request involves metrics or dimensions, The planner routes the task to Cortex Analyst, which is specifically designed to handle structured data found in semantic views. If the request involves conversational search over text, the task is routed to Cortex Search, managing unstructured data and RAG applications. Furthermore, the agent can use custom tools, such as stored procedures or user-defined functions, for custom logic or interacting with external systems. After the tools execute their tasks on their respective data sources, the results are sent back to the agent planner. The planner then combines these diverse insights into one unified final answer for the user. Cortex Analyst is treated as an opt-in feature within Snowflake. This means that access is not automatically granted to all users by default. The feature's availability is specifically controlled by the account-level parameter named enable_Cortex_Analyst. Administrators must explicitly set this parameter to true for the functionality to be usable in the account. To actually use Cortex Analyst once enabled, a user's role must be granted the Snowflake.Cortex_user database role, which grants access to all covered AI features, or the more specific Snowflake.Cortex_Analyst_user database role. This separation ensures granular control over AI feature usage. For deployment and integration, Cortex Analyst is primarily exposed through a convenient REST API, making it easy to embed into any existing business workflow or application. Developers frequently use the feature to build and run interactive conversational applications. These applications can be deployed internally using Streamlit in Snowflake, also known as SIS, or as standalone Streamlit applications running locally. When setting up such applications, the semantic model YAML file must be uploaded to a Snowflake stage, and the querying role needs appropriate privileges, including select access on the underlying tables defined in the model. This mind map outlines the necessary steps and methods for deploying and accessing Cortex Analyst capabilities. At the root, we focus on the deployment process. The first critical area is permissions, which includes the opt-in requirement controlled by the enable_Cortex_Analyst parameter, which must be set to true. Additionally, user roles must possess the necessary privileges, specifically the Snowflake.Cortex_user or Snowflake.Cortex_Analyst_user database role. The second major area covers deployment methods. The core way to integrate Cortex Analyst is via its REST API, allowing communication via the post message endpoint. Alternatively, users interact directly through the Snowsite user interface, especially for creating and managing semantic views. Finally, for conversational apps, solutions like Streamlit in Snowflake provide pre-built integration options. Central to all these methods is the semantic model, which is typically stored either as a YAML file on a Snowflake stage or defined as a native semantic view object. This map clearly structures the technical and access requirements for successful utilization of Cortex Analyst across the enterprise. Understanding the cost structure for Cortex Analyst is crucial for effective management of your Snowflake environment. The credit rate usage for the AI component of Cortex Analyst is based specifically on the total number of messages processed by the service. This is an important distinction, as the cost is not dependent on the number of tokens contained within each message, simplifying cost predictability. However, it is vital to remember that additional warehouse compute costs are incurred separately. These costs arise every time the SQL query generated by Cortex Analyst is actually executed against your Snowflake data, running within your chosen virtual warehouse. To effectively monitor these expenditures and track usage, Snowflake provides specific account usage views. You should query the Cortex_Analyst_usage_history view within the account_usage schema to view the credit consumption specifically attributed to Cortex Analyst. Furthermore, the general usage of AI services, including Cortex Analyst, is also aggregated and viewable in the metering_history view, where the service type is listed as AI_services. Monitoring these views allows administrators to maintain financial control and optimize usage efficiently. Monitoring these views allows administrators to maintain financial control and optimize usage efficiently. This ensures transparency in resource consumption and helps manage budgets effectively. This ensures transparency in resource consumption and helps manage budgets effectively. This ensures transparency in resource consumption and helps manage budgets effectively. This Gantt chart visually separates the two primary cost components associated with using Cortex Analyst and the corresponding monitoring tools. The first component is the AI processing cost, specifically incurred during the natural language to SQL translation phase, which is billed based on the number of messages processed. The second, larger cost component is the SQL execution cost, which uses your virtual warehouse compute resources. This warehouse cost is incurred when the generated SQL query runs against the structured data. Separately, the monitoring section highlights the views you use to track these costs. The Cortex_Analyst_usage_history view provides granular details on the AI message processing costs. The metering_history view tracks overall usage, including Cortex Analyst activities, categorized under AI_services. We have covered Snowflake Cortex Analyst, starting with its core function as a fully managed, LLM-powered feature that converts complex natural language into precise SQL for structured data. We explored the crucial role of the semantic model or semantic view, which provides the necessary business context, such as facts and synonyms, bridging the gap between user terminology and technical database architecture, thereby ensuring high accuracy and precision. We also saw how Cortex Analyst functions as a specialized tool within the larger Cortex agent framework, used specifically when the agent needs to query structured data, working alongside tools like Cortex Search for unstructured data. Finally, we reviewed the administrative aspects, including the opt-in requirement via the enable_Cortex_Analyst parameter, the necessary roles such as Cortex_user, and how to monitor costs using the Cortex_Analyst_usage_history view. The most important point to remember is that Cortex Analyst drastically simplifies accessing governed, structured data insights through natural language, accelerating data-driven decision-making across all business levels. The most important point to remember is that Cortex Analyst drastically simplifies accessing governed, structured data insights through natural language, accelerating data-driven decision-making across all business levels. The most important point to remember is that Cortex Analyst drastically simplifies accessing governed, structured data insights through natural language, accelerating data-driven decision-making across all business levels. The most important point to remember is that Cortex Analyst drastically simplifies accessing governed, structured data insights through natural language, accelerating data-driven decision-making across all business levels. This democratization of analytics is the primary benefit of the service within Snowflake. This democratization of analytics is the primary benefit of the service within Snowflake. This simple visualization emphasizes the core value areas of Cortex Analyst within the Snowflake ecosystem. The largest segment highlights the paramount importance of natural language to SQL accuracy. This accuracy is the foundation of the service, achieved through the intelligent use of semantic models and advanced LLMs. The next key area is the significant value Cortex Analyst brings by enhancing business user access. Now that you understand the concepts behind Cortex Analyst, your next steps involve hands-on application and continued learning about the surrounding ecosystem. Start by mastering the prerequisites necessary for establishing your semantic model, which is essential for accurate text-to-SQL translation, and properly connecting it to your structured data. Next, actively practice building conversational applications, either by calling the convenient Cortex Analyst REST API directly or by utilizing the pre-built examples available in Streamlit in Snowflake, SIS. It is also highly recommended that you investigate how Cortex Analyst seamlessly integrates with Cortex Search. This integration is vital for building holistic applications that can answer complex questions requiring insights from both structured tables and unstructured documents simultaneously, all orchestrated through Cortex agents. Finally, always prioritize monitoring and cost optimization. Regularly query the Cortex_Analyst_usage_history view to gain visibility into usage patterns and ensure efficient use of compute resources. remembering that SQL execution incurs separate warehouse costs. By mastering these steps, you can fully leverage the power of Cortex Analyst to accelerate data-driven insights in your organization. By mastering these steps, you can fully leverage the power of Cortex Analyst to accelerate data-driven insights in your organization. This continuous cycle of learning, testing, and monitoring is key to success with AI-powered analytics. This continuous cycle of learning, testing, and monitoring is key to success with AI-powered analytics. This ensures optimal performance and cost efficiency. This roadmap outlines the recommended progression for mastering Cortex Analyst, dividing the journey into 3 phases. The foundational phase involves first understanding the core concept of natural language to SQL conversion, followed by mastering how to create and manage semantic models, which are the engine of accuracy. The next phase is application and integration. This phase focuses on practical deployment, starting with integrating Cortex Analyst via the REST or Python API into custom applications. Then, you learn to integrate it as a key structured data tool within the robust Cortex agent framework. The final phase is operationalizing the solution.